Hey guys, Steven here. This is a different kind of video than I normally do. This video is going to be a little bit of a math lesson for everyone, so hopefully all skill levels and ages. I'm thinking from 5th grade up. So if you're 5th grade and up, any student, you should understand this. This is going to be a lesson about binary numbers. At the end of this video, you should be able to convert binary numbers to decimal numbers to binary numbers, and add and subtract binary numbers. So let's get started. I'm going to start off with something that seems very simple, and I should go ahead and apologize for my handwriting. I don't have a pen tablet or anything, so I'm just going to be drawing in handy-dandy paint, and then erasing like this. So in our normal number system, it's called decimal, and my paint thing just went away, sorry. Decimal. And it's the root of this is deci, meaning 10. Okay? So what that means is that we have 10 characters to work with in order to express a number. We have 0 through 9, which you'll notice the lowest one is 0 and the highest one is 10 minus 1. Okay? So we always have 10 minus 1 numbers that we can use. However, we have multiple digits. Now a digit, if you write a number like 100, a digit is each of these numbers in the sequence, okay? So in this case, 100 is a 3-digit number. And each one of these digits we can express with a number between 0 and 9. So that's going to be the underlying principle when we look at the binary number system. So let's quickly do a couple examples in decimal so that you understand some terminology. Now, when we're adding two numbers together, we're going to use the common method that people use, where they will add something like this with something else on top of it. You know, everybody's done this, and we'll add from the top down. And then the operator that we're doing will be right here, either plus or minus. So in this case, 8 plus 2, the leftmost digit is going to give us a 0. And then we have to carry the 1, as you know. This right here is called the carry out. It is the leftmost carry that we're using. So this gives us 10. Let's look at a slightly larger example to see if we can get a more interesting result. So we'll add 66 and 55. 6 plus 5, the sum is 1, and the carry is 1, okay? So we have a sum of 1 and a carry out of 1. Now, when we're looking at this column, let me just divide this up real quick. The left column, we have a carry in of 1, because this guy over here gave us a carry out of 1. So we add all three of these together. 1 plus 6 plus 5, that's 7 plus 5, or 12, which is 2 with a carry out of 1. And then we just bring the 1 down, okay? So here we have carry ins, which is what you have from the previous column. See, we had 2 carry ins, and then carry out is what you transfer to the next column. Okay, it's very simple, but it's very important. And remember that each of these can be expressed between 0 and 9 because our base is 10. This is called base, and I apologize for the handwriting, base 10. Okay. So what if we were to use a simpler system? What if we had just 2 numbers that we could express things with? What if we're using base 2? Let me write this up here so that we don't forget what we're doing. Base 2. Now remember, the rule of thumb is you have this minus 1, so we have 2 minus 1 is the maximum digit that we can use to display things. And remember, the lowest digit is always 0. So in base 2 system, we have 0 and we have 1 that we can use to make any number. That means that if you have a number which is 3 digits long, each digit has to be 0 or 1. And we can express all the same numbers, but as you can see, it's going to take longer for us to do it, okay? Now, in our base 10 system, which I'm going to draw a line down here to separate these two. So this will be, I'll just call this B10. In base 10, let's look at our example. Let's do 112. Now, 112, we can actually write this in an expanded form, where we look at each digit as a power of 10. So the first digit, and I'll explain this in a little more detail in a minute here. We have 10 squared. All right, let me just erase this so I don't have the wrong thing written here. Okay, the first digit is 10 squared, the second is 10 to the 1, and this one is 10 to the 0. Now, what does that mean? Well, 112 is really 100 plus 10 plus 2. You can see that this first digit right here is 10 times 10, but really this is 1 times 10 squared. Our next digit is just 10 to the first power, but really what we have is 1 times 10 to the first. And then our last digit is 2, but really what we have is 2 times 10 to the 0. And really, remember that anything to the 0 power is equal to 0. There are some rare exceptions that you look at in calculus, or sorry, oh my gosh, I said it's equal to 0. That is so wrong. It's equal to 1. That was a test, guys. Anything to the 0 is equal to 1. I apologize for that. Don't listen to this right here. Anyways, so anything to the 0 power equals 1, with some exceptions that we won't go into. But for our purposes, it is. So, what we have here is really not 112, but 100 plus 10 plus 2. And this works for any other number. If we have 567, what we have is 500 plus 6, d, plus 7. So we have 5 times 10 squared, because the third digit is always 10 squared. We have 6 times 10 to the first power, or 60, and then 7 times 10 to the 0, or 1. When you're looking at the first digit, it's not entirely clear what number system you're working in. But in this case, we have a 7, so we know we're not in binary, because in binary, we can only have a 0 or a 1. So let's take what we learned here about base 10 and apply it to base 2. That means our first digit is always going to be equal to 2 to the 0, or a multiple of 2 to the 0. Our second digit will always be a multiple of 2 to the first. And our third digit will always be a multiple of 2 squared. And the same thing repeats. You have 2 cubed, 2 fourths, 2 fifths, and so on. But we're just going to look at a 3-digit number for right now. Now remember that each of these can only be a 0 or 1. That means the largest number you can display or represent with the first digit is 1. Which is, if you have a 1 in this position, it's 1 times 2 to the 0. Now, if you're looking at, let me erase this. If you're looking at the second digit right here, the largest number we can display with only the second digit is 2, because it's 1 times 2 to the first. Now, if we combine that with the largest number that we have in the first digit, we can actually make 3, because we have 1 times 2 to the first plus 1 times 2 to the 0th. That's 3. But that's 3 in decimal. In binary, you write 3 as 1, 1. Okay? So let me clear out the stuff on the bottom here that we're not using anymore. It's like having a whiteboard, isn't it? So this is how we're going to represent numbers, and let's practice really quickly with converting. We're going to learn now how to convert any binary number into any decimal number. So let's look at an 8-bit number. Now 8, I'm going to draw all the blanks for it and tell you what the power of 2 is. Let's see, 1 2 3 4 5 6 7 8. Okay, so we know the first digit is always 2 to the 0. The second digit is always 2 to the first. Third is 2 squared, 2 cubed, 2 to the fourth. And keep in mind, these are the maximum value at that digit. So if we only have 2 cubed and the rest are 0, what we have is 2 cubed is 8 plus 0 plus 0 plus 0. So 1 0 0 0 in binary is equal to 8. But that's not what we're looking at this second. We're going to convert any number. So we have 2 to the 5th for the next one, which is equal to 32. 2 to the 6th is 64. And 2 to the 7th is 128. So I'm going to write these corresponding values underneath so that we can more easily calculate our number. 32, 16, And if you don't know these powers of 2, they're really simple. In order to get one, for example, 2 cubed is just 2 times 2 times 2. You have 3 2's, which represents the cubed. That's how you calculate the exponents. So this is 4, 2, and 1. And I'm just going to section these off. Sorry again for the handwriting. It's the best I got right now. I don't have a good enough camera to film this. So we know that anytime we see 2 to the 7th, or a digit into this, a 1 and 2 to the 7th, we need to add 128 to our answer, following what we did up here. Okay. So let's pick a random number. We'll do 0, 1, 0, 0, 1, 1, 0, 1. Now I just made this up. I don't know what the answer is going to be just yet, but I'm sure you're all intrigued to find out. And I'm just going to pull this down here so that we can get some more space. Okay, so let's just start from the left and write out all the digits that we have here in order to convert this. Remember, we're going from binary to decimal, decimal being our normal number system. So the first digit we have is 2 to the 6th, which our cheat sheet tells us is 64. So we add 64. We'll just put an equals. And our next digit, we have a 0 here, so we don't use that one. We have a 0 here, so we don't use that one. We have 2 cubed, which is 8. So let's add 8 to our answer. Next, we have 2 squared, which is 4. And finally, we have 2 to 0, which is equal to 1 by our cheat sheet. So we can add all these together, and we get 64 plus 8 is 72, plus 4 is 76, plus 1 makes 77. So our answer for 1001101 is 77. Now keep in mind, there's only one way to represent any number in binary, okay? You can't represent a number in 2 different ways. So anytime we see 01001101 by itself, we know it's equal to 77. And that's a handy trick, because numbers like this are standardized, meaning every computer will read this as 77. It wasn't always that way, but that's how it is now. So that's a really quick and dirty example of how we convert from binary to decimal. Now, how do we go the other way around? This is a little bit trickier. What we're going to do, and I'm going to leave the cheat sheet here, we're going to use the principle that there is only one representation for every single binary number. So let's start off with we're going to do a semi-challenging one. Let's try 86, okay? This is what we want to make out of binary numbers. So we want to figure out what 86 is in binary, okay? So this is how I do it. There are many, many ways to do this, but I'm going to tell you my simple, easy way. My phone just went off. So what I like to do is look at the biggest number in this list that goes into 86. Now, your maximum number that you write will need to be greater than 86, and in this case we have 128, so that's good. 86 isn't bigger than 128, so we know we can make 86 using all the numbers to the right of 128. So the largest number we have in this list is 64. So we know that I'm going to keep a running tally on the bottom here of what we have so far. So we have a 1. So now what we're going to do is subtract 64 from 86, because remember before we were adding these numbers up, right? Now we're going to subtract them. So 86 minus 64 gives us a remainder of 22. So now we're going to find the greatest number that is, the number on the chart that's greater than 22, and we'll draw our line again. So we can see that 32 is greater than 22. So we're not going to use 32. So we can go and actually put a 0 right here, because we know we're not using 32. This is kind of confusing, but if you try it a couple times, you'll get it. So let's find the largest number right of the line, which goes into 22. And very clearly, we can see that it's 16. So we're going to subtract 16 and put a 1 for the fact that we use 16, okay? And we get 6. So now let's find the largest number on the list that is less than 16, less than 6. So that's going to go here, because 8 is greater than 6 and 4 is less than 6. So we're not going to use 8, so we put a 0. And we're going to look to the right of this to find the next largest number. So 4 is next, so we'll subtract 4. And that gives us 2. Since we used 4, we're going to put a 1 in the 4 position. And now what we're left with is 2. So we can draw our line right here, and we know we're using 2. So minus 2 equals 0, just for thoroughness. So we use 2, so we have to put a 1 here, but we're not using 1, 2 to the 0, that is. So this 1 right here, we're not using it, so we put a 0. So now, since we didn't use 2 to the 7th, you can put a 0 in the front, but it's not any different. Just like in decimal numbers, if you write 555, that's equal to 0.000555. It's the same number. It's just easier to cut off all this crap at the beginning here. So our final answer is this, 1010110. And you can check this if you like to make sure that it does actually equal 86 by using the chart right here and using the values. So that's how we convert a decimal number into a binary number. And all you have to do to use a larger number than 128 is just keep up this chart. The next number is 256 and so on. You just get these by multiplying the previous one times 2. And there you have it. So let's do some binary addition. This should be fun, right? I know some of you probably disagree with me on that, but that's okay. I find this fun. So let's do a quick example, and I'm going to show you the principle of how we do binary addition. And it is very simple. Let's do an example of numbers that we know. So let's do 5 plus 6, which we know gives us 11. Okay? So I'm just going to write the corresponding number next to it. 5 is 101 because this is equal to 4, and this is equal to 1. 4 plus 1 is 5. 6 is 110. We know that because this first number is equal to 4, this one's equal to 2. Oops. 4 plus 2 makes 6. So adding these together is exactly the same as it is normally. You go column by column and you use the carries. 1 plus 0 is always going to be 1. 0 plus 1 is also 1 because it's the same thing but backwards. And you're able to do this like you do normally. So if we add 1 and 1, we get 2. But in binary, the way we write 2 is 1, 0. So we're going to have a 0 for the sum. This is the sum. And then our carry is going to be 1. So we just write the 1, we would write the 1 up here, and then we bring it down because we're done with the equation. So we're left with 1, 0, 1, 1. Now let's check and see, using our method, if this is actually what we expect. Now we have 4 digits, so our largest power of 2 is going to be 8, which is 2 cubed. So we have 8, and we're not using 4, but we are using 2, and we're using 1. So you can clearly see 8 plus 2 plus 1 is 11. Now, I'm going to cut this video off here and do subtraction in the next one because it is a little bit more complicated. But I hope that you understand how binary numbers work, and if you don't, watch it again from the beginning, or even open up the Wikipedia article, which has some tables on how to convert common numbers between, I think, 0 and 8 at least, if not higher. In the next video, we'll look at subtraction, and after that, I'd like for us to look at hexadecimal system, which, unlike binary, which is base 2, and unlike decimal, which is base 10, uses a base 16 number system that lets you convert from binary directly into it. So thanks for watching. I hope you enjoyed this, and I hope it was low enough level. If you have any criticisms or compliments or any kind of feedback, feel free to let me know. And if you need further examples, I will give you plenty. Thank you for watching, and goodbye.